Hey guys, we are going to review ratios, proportions, geometric mean, and similar figures today. Starting with some ratios, the angles of a triangle are in this extended ratio, 5 to 6 to 7. Find the measure of each angle. So that means in a triangle, I can say that the angles are 5x, 6x, and 7x. And if I add those triangles together, 5x plus 6x plus 7x, if I add those angles together, I know that in a triangle they must add up to 180. 5x plus 6x is 11x, plus 7x is 18x, equals 180. And I can divide by 18 and get x is 10. So the three angles are 5 times 10, 6 times 10, and 7 times 10, which would be 50 degrees, 60 degrees, and 70 degrees. And before I put a box around it, let's check that. 50 plus 60 plus 70 really better add up to 180, and it does. So that means that these are correct. Okay, solving proportions. We're going to do that with the cross products property. Multiply across 10 times x, and 8 times 15 is 120. And I can divide by 10, and I get x is 12. Okay, now when I do cross products here, I'm going to distribute this 2, so I get 2m plus 10, and I'll distribute this 3, and I get 3m plus 3. Now I can subtract 2m, and at the same time I can subtract 3, and I get 7 equals 1m, so m is 7. The geometric mean is the nth root of the product of n numbers. I have two numbers, so it's the second root or the square root. And for a square root, I do not need to write a number in here because it's just understood as a 2 if there's nothing there. The square root of 20 times 24. Now when I multiply these, I don't think I'm going to get a square number, and I'll just skip the process of finding out. And if I end up with everything coming in pairs, that's fine. Then I don't have anything left under the radical, and it would have been a square number. So I've got 5 times 4 is 20. And 4 is 2 times 2. There's a pair of 2's. 24 is 4 times 6. 4 is 2 times 2. There's a pair. 6 is 2 times 3. So there's no more pairs. So what comes in pairs is a 2 times another 2, and that's what comes outside of the radical. The leftovers at the bottom of the branches are 5 times 2 times 3. Okay, so that's 4 times the square root of 5 times 2 is 10 times 3 is 30. So there is my geometric mean. Okay, find the length of segment BD. Okay, so I have 24 is to this longer number, 24 plus 8, which is 32. 24 is to 32 as this shorter number, BD, is to this longer number, 20. Okay, so my cross products are 32 times segment BD, and then 24 times 20. Is 480. And divided by 32 will give me the length of segment BD. That should be a 3-2. And that gives me 15. So the length of BD is 15. A model of a building has a scale of 1 inch to 20 feet. So on the model, so let's just say this is a model building, and this is the real building. 1 inch length on this model represents 20 feet on the actual building. Okay, the length of the actual building is 250 feet. The height of the model is 8.5 inches. So we want to find the height of the building and the length of the model. Okay, so let's start with the height of the building. Okay, so we're going to do height over height. So 8.5 over h. Okay, and I did small over large because right here is small to large. It equals 1 over 20. Okay, so small height over the large height equals the scale factor small over large. So I've got 1h equals 8.5 times 20. And that is 170. So the height of the building is 170 feet. Okay, now the length of the model, I'm still going to do small over large. The length of the model over 250 feet equals the scale factor small over large, 1 over 20. So I get 20L equals 1 times 250. And then divide by 20. So the length of the model is 12.5 inches. All right, now these similar figures, we need to find the scale factor of ABCD to EFGH. Okay, now ABCD, something from ABCD has to go on top, so that's going to be this larger one. Okay, only because it's listed first. Since ABCD is first, it goes on top. Okay, so I need numbers that correspond with each other, and it looks like I can use 15 over 6 or 5 over 2. And it really doesn't matter because 15 over 6, 3 goes into both of those, 5 times and 2 times. So the scale factor is going to be 5 over 2. Okay, now let's go way down to the bottom. The ratio of perimeters ABCD to EFGH. All right, a little secret just between you and me. The scale factor is exactly the same as the ratio of perimeters. So this is going to have to be 5 over 2. Okay, now let's find the value of x. So here is x, and x is on HE. First and last letters corresponds to AD right here. So that's 10 and x. Now I have a scale factor of 5 over 2. And that's large over small, so I'll go large over small equals 10 over x. Okay, now cross products are 5x and 20. And I divide by 5 and get x is 4. Okay, now the value of y. Y is here on GF. So GF, that's these two middle letters, so that goes with BC. So y goes with 20. And we're going to start with the scale factor. 5 is to 2 as, and that's large over small. So large over small, 20 is to y. Cross products are 5y and 40. And 40 divided by 5 is 8. Okay, the value of z. Z is an angle measure right here in angle G. Angle G corresponds with angle C. So these two angle measures are the same. In similar figures, the sides are proportional, but the angles are exactly the same measures. So Z is 41. Okay, the perimeter of ABCD. To do that, all I have to do is add up the sides of ABCD. 10, 5, 20, and 15. 10 plus 5 plus 20 plus 15 is, okay, so let's see here, 10 plus 5 plus 20 plus 15 is 50. The perimeter of EFGH, and I've got two different ways I could do this now. I could write a proportion. 5 is to 2 as, so the scale factor, large over small equals perimeter, large over small, 50 over, and I'll call it P for perimeter. So if I do it this way, then I do my cross products and get 5P equals 100, and divide by 5 and get P is 20. So the perimeter of the smaller figure EFGH is 20. I could also just add up the sides because I've already found X. X is 4. I found Y. Y is 8. And if I add these up, 8 plus 2 is 10, plus 4 is 14, plus 6 is 20. So I could have just done 8 plus 2 plus 4 plus 6 equals 20. Either way, I'm going to get that same perimeter. And the perimeter ratio, okay, if I forget that the scale factor and the ratio of perimeters is the same, then my ratio of perimeters, ABCD, perimeter of ABCD is 50. Perimeter of EFGH is 20. And that simplifies to 5 over 2. Now, what if right here actually said EFGH to ABCD? So it was backwards. Whichever one is first goes on top. So if it said EFGH to ABCD, then I would have to put 2 over 5.